continue with what we do. So our workflow is based, or the idea is that we can be reduced by local communities everywhere in the world where they have the possibility to collect data, drones, and imagery. So after the data acquisition, you can use tools like Mapstat, where you can label the data or use the help of volunteers or local communities to label the data for later use in model training. So we tried it out a little bit for labeling the data. In the end, I still went through all the labeled data again to make sure it works really well, that the model is in the possible data. But we found out that the labeling worked really well with the volunteers in Mapstat. So they just went to the images and said, okay, if you're a race part or not. And that in the end of the day, they labeled it more or less the same way as I would do. So it was really good. And after the model training, we can apply this on the whole city of Salaam, where we have the data. And we can use the resulting data to create an indicator of urban waste contamination, and also use this data, external data, to make flooding risk, clogging risk assessments, and different other analysis. And we hope that this can be used in the end by local actors to take action in the field. So now I go through step again. So we have two different models, as I said. We have data sets. Both are created by OLP here in Salaam. One was created by via drone imagery, and one was created using street-view-imagery. And they are really great data sets. So I don't know if you know about this street-view-image data set, but it covers a huge part of the city. Every road is covered, and every 5 seconds there's an image. So huge data set that can be used for many opportunities. And it's already also a 360 imagery, so a good data set here. But I will start with the drone imagery. It was taken along the Salaam River here in Salaam, or multiple rivers, but used for a model only the region around the Salaam River. And here we trained the object detection model based on YOLO, and we just divided the drone imagery into smaller patches and detected for each patch how many waste piles there are in the image. And I can show you the result here. I hope it's not more or less visible. So on the top left, you can see how it looks like. You have this image patch, and on it you have the bounding boxes around each waste pile that is detected. And you can see the contamination here found out that the most contamination of waste is along the riverbed and in the vegetation. So which is obviously not good for in flooding scenarios or so. And yeah, that can also already be used like actually. I can show you how it looks for some examples here. It works really well in most places, but we have some limitations here. False positives like reflections on water, or here you have clothes that are laying on the ground, which are not waste, but it looks very similar to waste. So that's some issues that can be improved. But overall, it has a really high accuracy of nearly 80%. So really good. But we found out that one big issue is that a lot of waste piles are obstructed vision from the drone. So there are trees or rooftops above it. We can see that on the right. We know there's a waste pile below those trees, but the drone cannot see it, so the model cannot detect it. And that's why we got the idea that we can use this really good data set of street imagery to also detect those waste piles. And for that, we used this street imagery data set I hope you can see it on the right side. You can see the coverage, so it's really massive. With that. Here we subdivided city geometry to reduce the computational load. So we have more stripes and detected the weight files on those stripes and not on the whole city geometry. And yeah, as I said, we use NetSwap for labeling both data sets. And for this, we created this new, now not that new anymore, NetSwipe to use NetSwipe on street-view-imagery for metallery. And yeah, that worked really well. We can use security. And yeah, we also labeled with the traditional NetSwipe approach the weight on the photo material and generalize that side. In the end, our street view imagery model had a really high performance of around 90%. And we applied the model on the whole data set. So not on every image, but every 10 meters of image, because the coverage is really high and you don't need information for every 2 meters, but every 10 meters is enough. And yeah, that I will show you the results in a minute. So before that, I want to show you that the model actually works really well in identifying weights. So it's not an object detection model anymore, because we decided it's not important on the street view imagery. If you know if the waste pile is here or here, that's important to know on this position in the city there's a waste pile somewhere. And because we cannot estimate the volume of the waste pile anyway, because for that we need more data like data to estimate it. And so we use the more easier way of using a classification model, also based on your version 11. And here you can see the activation map that the model actually, the most important points of the model are actually the weight size. Hope you can more or less use with the resolution. And that's really great because it shows us that the model really detected what we want to do and can be applied, hopefully, for other cities as well later, or it's easier to find them for other cities as well. And so here are the results for our indicator. So we had 2 different models actually for the street-view imagery. One model was trained to detect waste that's in waste bags already, and one that detects the piles itself. So on the left side, you can see the trash bag detection, and the brighter the color, the more detections are on this point, because we have this split image approach. So now say that the detection is in that direction, or in that direction, and that direction. So you know, if there's a lot of detections in multiple directions, that probably there's more waste in this than in other places, but could still be that there's only small piles and somewhere else there's a really big pile in only one direction. It's not a perfect metric, but we can be useful in places. And on the right side, we also added this is in this light blue color, our detection from the phone imagery. And we found out something interesting here. That if you look here, that's we cannot really good see it here, but that's the area where the phone imagery was available that intersects with the street-view imagery in some places. And we try to compare where detection in both data sets, in both methods. And we found out that there's nearly no overlap in the area where data overlap with detection. So you need both approaches cover the area completely. So you need drone imagery for backyard and in vegetation where street view imagery cannot access. You need the street view imagery to detect waste piles that are covered by rooftops or trees. Now we have this data, and we wanted to highlight that it can be actually used. We created a really simple logging with index, where we use the really good data of the training system in OpenStreetMap and just estimated by the amount of waste file detections from the model around the training system, replace how much volume of waste will be in this training system in a flooding event, and where it will start logging. And found out that in some areas here there's a really high logging risk. It's not a perfect analysis, so that's not the result that I would bet on, but we wanted to highlight that we can do something with the data. So data can actually be used for such things, and we hope that it can be used in the end to improve local awareness or help the local stakeholders to show why it's important to improve waste management in regions. So expect something like, okay, you can create maps now with this data and show it in a with a local community. Here you have you're in an area with high logging risk based on waste. So it's important for you that that waste management is improved, or for official agencies to highlight here that's the area where the action is most required. So it's still not perfect, the model, and we have the problem that it's direct. It's in the moment the model is finished, it's already outdated. It's a quickly changing topic. The object, the waste files can be away in the point when the data is uploaded already. So you have to frequently do this the data acquisition again if you want to monitor the waste in real time, but can help to know probably areas where high waste was back then that go today. Maybe not on the same place, but in the same area. That's what we expect. And we didn't finish this project yet, so we continue working on it. Actually, we started applying this model or extending the drone imagery model to more cities from Africa. So we did it for, I think, nearly 50 cities where we found beautiful data on OpenAreaMap. And we got really good results there too. So the goal is to create a model that can be applied everywhere, or it's really easy to improve for your local context. And that's why we are currently working on integrating the waste model into a hot pair project. I'm sure if everyone is aware that it exists. Here, at this point, you can fine-tune a building detection model that already exists to your local data. So we create a model that works for your area of interest, really good, and it's easy to do there because the computation and everything happens on their side. But you only have to create the data there. You can upload your original data, you can add new data, you can improve the data in the tool, and then this data is used to improve this model. And we are recently working on doing adding this waste model there. You can use this model as a starting point and improve it with data you acquire locally, and then apply a new local context for hopefully better accuracy in the end. And we also are currently working on doing something similar with our street-view model. So here we started implementing a pipeline on Panorama. Panorama, for the people that don't know, is like an artillery where you can upload city imagery, and it's openly available for everyone. But in artillery, the benefit is it's completely free and open source. So it's a federated system by volunteers, deeply connected with OpenStreetMap. So hopefully more and more users will use it. And the important thing here is you can do the same as in artillery, to apply models to automatically detect something from the imagery, but here you can add models on your own. So you're not required to use the closed source models by Hillary that are often not more trained on North Africa and North America and Europe, and not on areas in the global south. And we cannot insert your own models there. And that's what we do, that you can add any model that uploadable to Hugging Face is more or less the open GitHub version for machine learning models. And that it can be directly implemented into Panorama so that every image that is uploaded can be can use the model on, and then the data, the annotations that are created there are also openly available for everyone that's using Panorama. I want to show it to you. We have it already here where I implemented the weights model. We have here some annotations. Excellent. Okay. This image we found from the waste was detected. Somewhere in this image is the waste file, so really here cannot be so. Okay. Okay. Yes. Perfect. Okay. Yeah, you can see we have here an annotation box where there's more information about the whole detection. So there's also the classification score, how true is the model, that there's really a right detection. And we also started adding that you automatically add the right OpenStream text to it. So you could upload the data, you can do it directly, you could verify it, but the data is in a format that you can verify it and directly upload it to OpenStreetMap from Panorama after verifying it. So and we can do the same here, not only for classification of IBIS, but we can do it with models for image segmentation or object detection. So we use here stuff, random models we found on Hugging Face and applied it to the data here in Madagascar. And you can see it works really well already for car detection here. And the model was in fine system. So you can use any model you find somewhere, improve it for your local context, and then use the Panorama here in our pipeline to generate this data that can be used directly after creation. And it's open, completely open and free. So I think that more or less it for my part, but I am really interested in if you have some ideas for use cases for this. So obviously it's great that we can create such a model, but the important thing is that some more data needs to be used somewhere. So ask some questions, come around. I'm at the Highgate booth after this presentation, and I'm really happy to hear from you. Thank you.
Thank you. It's time for the questions. I welcome anyone with the questions. Okay, welcome.
Okay, this is also another interesting presentation from you. I just want to ask you one question out of curiosity. Just could this effort be adapted to detect like other urban issues? Like I was thinking of damage, fraud, or flooding.
I hope I helped it.
Yeah, I mean, yeah, the approach you implemented here in this project.
Yeah.
Can we do the same for like some way to take the road issue, maybe flooding, the thing of course can be influenced.
Yeah. So as you know, this is in applying it somewhere else, but something we hopefully will do soon, that we have more topics models where we apply this to a workflow. And as I said, the great thing about it is we can really do it in all this open software, local communities, they can do it on their own. The biggest thing is data acquisition. We need to get data. So the data set from all these sets is really good for the Salaam, can be used for more things, definitely. If we use only for more things. And yeah, then we need some people that will label the data, but you, as a custodian, can also use volunteers, and that's what currently, I think, relabel this data.
Thank you. Any other question? Any other question? The backbencher there, is there a question? Okay, if there is no question, let me take this opportunity to ask you a question. I have seen that we have used the one application, the map swipe. Is it the same application that is doing the spatial analysis, or you have to extract the data from the map swipe application and then install it into another application for the analysis section?
Okay, no, so we had a data set where we downloaded the data from the auxiliary, and we moved for every limited ID the location, but can also get data from MATLAB directly. That's it for the safety. Point in coordinate, depending from the from MATLAB directly. I just use it from my auxiliary because it's better used in my workflow because I had some relabeling already.
Okay, thank you. We still have some time. If there is anyone with the question or with any contribution on the presentation from our fellow Levy. Okay, if there is no question, there is no any comment, let's have a warm round of applause to our presenter. Thank you. Thank you so much. Okay, we are going to have another presenter with us. But before we step up for the next presentation, I see some kind of people like Philippe